Here we go. Example 2, a 10 kilogram block is lifted at a constant velocity at the top of 20-meter building in 25 seconds. So I know a couple of things. I know this, right, is time. I have a distance, which is 20 meters, and look at this. I have a weight. Interesting. This weight here, right? But really it's a mass. So we have to calculate the weight. Okay, so here we go. Here's the weight, which is Fg, remember, is equal to the mass times the acceleration due to gravity. I'm going to make that into a G. My mass is 10 kilograms. My gravity is 10 meters per second squared. Notice lifted, so I'm going to make this negative. Right? Remember, gravity is going down, and so we're going to assume that that is in the negative position, negative direction. So this ends up being a negative 100 newtons. What is the net force acting on the block? Well, you can see here that it says that this is at a constant velocity, so the net force is going to be 0, F net is 0 newtons, right? Balanced forces. So what's the applied force? Again, you can write this out, right? You know that F net is equal to Fg plus Fa, right? Your F net is 0, and that's equal to your negative 100 newtons. Sorry, let me just make sure that that is correct. Plus your Fa, right? When you do the math, your Fa ends up being positive 100 newtons. Okay, you don't actually need the math to know that, right? You just know that the net force is 0, so they have to balance each other out. So the Fg is negative, that means Fa is positive, and they are the same amount, or the same value. So then what is the power of the motor? So now notice you have Fa, and our power equation, power is equal to, we know that it's work divided by time. Fantastic, but we don't have work, so I'm going to substitute my work equation in there, right? My work equation is force times distance over time, right? I just substituted my work equation into, or instead of work. So now I have my force. So my force is this 100 newtons, right? And I'm going to multiply that by my distance of 20 meters. And then divide that by my time of 25 seconds. When I do the math, I get 2,000 joules, right, divided by 25. Okay, so this ends up being 2,000 joules, so that's my work, right, divided by 25 seconds. That's going to equal my power of 80 watts. Good. The last part is just really easy. I mean, I call it easy because it's just the proportion, right? If a new forklift has twice the power of the old one, notice, here we go. Twice the power. Okay, that means this is 2P, right? My new work is twice P. How much, or sorry, my new power is work. How much more work? So that's what we're looking for. We're looking for W prime. can it do in the same amount of time? That's purple, same amount of time. So what is constant? Our constant is time. What's the proportion statement? Let's look it up. Scroll up. P, if T is constant, is this guy here, right? If T is constant, then P is proportional to W. Okay, so let's go back. P is proportional to W. Fantastic. What's the new work? Well, work prime, right? Notice if P doubles here, right? If P doubles here, that means my new work is double as well, 2W. What is the equation for work? It is going to be, I guess I'm not exactly sure what it's asking. So I'm not going to answer it. I'm going to strike that out. All right, all done.